Hello everybody, it's me, Code Choker Looter, signing in for another episode, chapter 2 or part 2 of the Learning C Sharp series. And here we have the chapter number 2 actually of the book. We're going to keep reading. We're going to chapter 2, data types and operators. We have seen a lot of similar things here that are going to be here with the Python and the JavaScript courses, but there are some other data types that I would like to cover. Therefore, we're going to keep reading these little, what do you call it, page of the book in order to grasp more about the structure of the program, shall we? So, without further ado, Chapter 2, Data Types and Operators. In the previous chapter, we learned about .NET Framework and understood the basic structure of a C# program. In this chapter, we will learn about data types and objects in C#, alongside control statements, which we will explore in the next chapter. These are the building blocks of every program. Excuse me. We will discuss built-in data types, explain the difference between value types and reference types, and learn how to convert between types. We will also discuss the operators defined by the language as we move on. Oh my gosh. Please shut the fuck up. Thank you. The following topics will be covered in this chapter. Basic built-in data types, variables and constants, reference types, nullable types, arrays, type conversion, and operators. Okay. Basic data types. In this section, we'll explore the basic data types. The common language infrastructure defines a set of standard types and operations that are supported by all programming languages targeting the CLI. These data types are provided in the system namespace. All of them, however, have a C# alias. These aliases are keywords in the C# language, which means they can only be used in the context of their designated purpose and not elsewhere, such as variable, class, or method names. The C# name and the .NET name, along with a short description of each type, are listed in the following table. So we have here bool, for example, that's the C# type name, system boolean, and the description represents a boolean value. It can be set to true or false. Byte, system byte, represents an 8-bit unsigned integer. Character, system char, represents a UTF-16 code and unit. Decimal, system decimal, 128-bit data type suitable for financial calculations. Double, system double precision floating point value. Float, system single precision floating point value. Integer 32 represents a 32-bit integer value. Long represents a 64-bit integer value. SByte represents an 8-bit signed integer. Short represents a 16-bit signed integer. Uint, short a 16-bit signed integer. Uint represents a 32-bit unsigned integer. Ulong, oh gosh, there you go. I think that's better, right, guys? Ulong represents a 64-bit unsigned integer, and ushort represents a 16-bit unsigned integer. The types listed in this table are called simple types or primitive types. Apart from these, there are two more built-in types, object and string. Object is the base type for all reference and value types. String, a string of UTF-16 code units. Let's explore all of the primitive types in detail in the following sections. The integral types. C# supports 8 integer types that represent various ranges of integral numbers. The bits and range of each of them are shown in the following tables. Byte, SByte, short. Here is... Jesus, there you go. Here, guys, you can make a screenshot out of this. I think that's suited better. Byte, SByte, short, ushort, integer, uinteger, long, and ulong. You can see the range of their of each type. As shown in the preceding table, C# defines both signed and unsigned integer types. The major difference between signed and unsigned integers is the way in which the high order by its order bit is read. In the case of a signed integer, the high order bit is considered the signed flag. If the signed flag is 0, then the number is positive, but if the signed flag is 1, then the number is negative. The default value of all integral types is 0. All of these types define two constants, called mean value and max value, which provide the minimum and maximum value of the type. Integral literals, which are numbers that appear directly in code, can be specified as decimal, hexadecimal, or binary literals. Decimal literals do not require any suffix. Hexadecimal literals are prefixed with 0x or lowercase x or uppercase x, and binary literals are prefixed with a lowercase b or a uppercase b, a byte. So I think it's a bit and a byte. And an underscore can be used as a digit separator with all numeric literals. Examples of such literals are shown in the following snippets. Integer decimal, 32, hexadecimal, okay. Integer bin, an integral value without any suffix, is inferred by the compiler as integer. To indicate a long integer, use a 1 or L for a signed 64-bit integer and a U1 or UL for an unsigned 64-bit integer. The floating point types. The floating point types are used to represent numbers having fractional components. C# defines two floating point types, as shown in the following table. Float 32, which we have seen in Python and JavaScript, and we have double, which you can store a bigger, divisible number. The float type represents a 32-bit single precision floating point number, whereas a double represents a 64-bit double precision floating point number. These types are implementations of the IEEE standard for floating point arithmetic, which is a standard established by the Institute of Electrical and Electronics Engineers in 1985 for floating point arithmetic. The default value for floating point type is 0. These types also define two constants, called mean value and max value, that provide the minimum and maximum value of the type. However, these types also provide constants that represent not a number, and infinity, and system double positive infinity. The following code listing shows several variables initialized with floating point values. Okay. Double C. By default, a non-integer number such as 42.99 is considered a double. If you want to specify this as a float type, then you need to suffix the value with the F or F character such as in 42.99, or just like that. Alternatively, you can also explicitly indicate a double literal with the D or D suffix, such as an 42.99D or 42.99D with the uppercase D. Floating point types store fractional parts as inverse powers of 2. For this reason, they can only represent exact values such as 10, 10, 20, 10, 10.25, and 10.5, and so on. Okay, decimal type. Decimal type can represent up to 28 decimal places. The details for the decimal type are shown in the following table. Type, bits, and range. Decimal 128. The default value for the decimal type is 0. Mean value and max value. Constants that define the minimum and maximum value of the type are also available. A decimal literal can be specified using the M or M suffix as shown in the following snippets. Okay, it is important to note that the decimal type minimizes errors during rounding but does not eliminate the need for rounding. For instance, the result of the operation 1m, is not 1 but 0.9999999. On the other hand, math that round 1m yields the value 1. Okay. The decimal type is designed for use in applications where precision is key. Floats and doubles are much faster types, while the decimal type is slower, as the name implies, it uses decimal math, which is slower to compute. The decimal type can be an order of magnitude slower than the double type. Financial applications where small inaccuracies can accumulate to important values over repeated computations are a typical use case for the decimal type. In such applications, speed is not important, but precision is. The chart type. The character type is used to represent a 16-bit Unicode character. Unicode defines a character set that is intended to represent the characters of most languages in the world. Characters are represented by enclosing them in single quotation marks. Examples of these include A, B as uppercase, then C as lowercase, and the U0058. Okay. Characters values can be literals, hexadecimal, escape sequences that have the form XTD, or Unicode representations that have the form /UDDD, where DDDD is a 16 hexadecimal value. The following listings show several examples. The default value for the chart type is decimal 0 or its equivalent. Okay, the Boolean type. C# uses the bool keyword to represent the Boolean type. It can have two values, true or false. Okay. The string type. String is an array of characters. In C#, the type for representing a string is called string and is an alias for the .NET System string. You can use any of these two types interchangeably. Internally, a string contains a real-only collection of chart objects. This makes strings immutable, which means that you cannot change a string but need to create a new one every time you want to modify the content of an existing string. Strings are not null-terminated and can contain any number of null characters. The string length will contain the total number of the char objects. Strings can be declared and initialized in a variety of ways, as shown here. String s1 is equal to null, initialize, okay. I don't know if you guys can see well over here. It is important to note that the only situation when you use the new operator to create a string object is when you initialize it from an array of characters. As mentioned before, strings are immutable. Although you have access to the characters of the string, you can read them, but you cannot change them. The following are the methods that seem to be modifying string. Remove. This removes a part of the string, and to upper or to lower, this converts all of the characters into uppercases or lowercases respectively. Neither of these methods modifies the existing string, but instead returns a new one. In the following samples, is the string defined earlier, S8 will contain hello, S9 will contain hello world, and S6 will continue to contain hello world. Okay. You can convert any built-in type such as integer or floating point numbers into a string using the toString method. Okay. Let me see something here, guys. Right, guys. Long story short, I wanted to see if we're actually gonna do some exercises in this chapter. There's one exercise only in this chapter only. So whenever I'm gonna do this. How you call it? After each after or in between each chapter, what I'm gonna do is I'm gonna copy all of these code snippets. I'm gonna put it in one single file or in different files to upload it into my GitHub, and then I'm gonna show you what they actually show in the output, and in the console output. But so far, yeah, we only have like one very long code exercise in this chapter, which hopefully we'll do it very soon. But I think in this part of this video, we're gonna focus only in basic data types, and then next week we're gonna do variables and stuff like that. Okay. So yeah, let's get going with that. Okay. So it is important to note that all the situations when you use the new operator to create a string object is when you initialize it from an array of characters. As mentioned before, strings are immutable. Although you have access to the characters of the string, you can read them, but you cannot change them. The following are the methods that seem to be modifying strings. Removed. Okay, yeah, we already. Okay, yeah. We read all of that. Okay, strings can be composed in several ways. It can be done using the concatenation operator. Using the format method, the first argument of this method is the format in which each parameter is indicated positionally with the index specified in curly braces, such as, okay, and so on. Specifying on index beyond the number of arguments results in a runtime exception. Okay. An example of all of these methods is shown here. Oh, okay, now I understand. Some characters have a special meaning and are prefixed with a backlash. These are called escaped sequences. The following table lists all of them. Okay. Let's see. Take it. Okay, backward single quote, double quote, backlash, null, alert, backspace, form feed, new line, carriage return, horizontal tab, vertical tab. Okay. Escape sequences are necessary in certain cases, such as when you specify a Windows file path or when you need a text that spans multiple lines. The following code shows several examples where escape sequences are used. Okay. Right. You can, however, avoid using escape sequences by using verbatim strings. These are prefixed with the symbol. When the compiler encounters such a string, it does not interpret escape sequences. If you want to use quotation marks in a string when using verbatim strings, you must double them. The following sample shows the preceding samples rewritten with verbatim strings. Okay. Okay, don't worry guys, because I'm gonna make different code projects for all of these methods that we can see over here. And put it on my GitHub. The object type is the base type for all other types in C#, even though you do not specify this explicitly, as we will see in the following chapters. The object keyword in C# is an alias for the .NET System object type. You can use these two interchangeably. The object type provides some basic functionalities to all other classes in the form of several virtual methods that any derived class can override, if necessary. These methods are listed in the following table. Equals finalize get hash code into string. You can pause this so you can read it or take notes of it. Apart from these, the object class contains several other methods. An important one to note is the getType method, which is not virtual and which returns a system type object with information about the type of the current instance. Another important thing to notice is the way the equals method works, because its behavior is different for reference and value types. We have not covered these concepts yet, but we'll do so later in this chapter. For the time being, keep in mind that for reference types, this method performs reference equality. This means it checks whether the two variables point to the same object on the heap. For value types, it performs value equality. This means that the two variables are of the same type and that the public and private fields of the two objects are equal. The object type is a reference type. The default value of a variable of the object type is null. However, a variable of the object type can be assigned any value of any type. When you assign a value type value to object, the operation is called boxing. The reverse operation of converting the value of objects into a value type is called unboxing. This will be detailed in a later section in this chapter. You will learn more about the object type and its methods throughout this book. Okay, guys, and with that, we'll conclude the part 2 of learning C#. All the methods, as I previously said, all the methods that appear here are going to be shown in my GitHub page in the Learn C# Chapter 2 repository that I have. So do not fret that I haven't done any C# code just yet. We're just learning about this, but don't worry because all those methods are gonna be there, and you can use those in order to create your own exercises. Okay, so thank you very much, guys. If you like this content, please click like, subscribe, and see you guys next time. Okay, thank you.